Welcome to this solution video. If you like this video, please share with your friends and subscribe to my channel and motivate me to make more such videos. Let's start with question number 1. Find the constants a, b and c such that this rational part becomes equal to the other part. So now to find those values, first step should be that we should separate p, q and r with their exponents. So this p becomes p to the power half because square root p is same and this square root is only over p, not with q, not with r. So q is already there, 2/3, r is power minus 3 divided by when we have a bracket and some exponent over it, we should distribute it among the parts which are inside the bracket. They are multiplying, so we can give this to each one of them. So p square, q minus 2, r minus 1. Okay, second step should be that p and its exponents are separated. So half is there and 2 is there. But because they are dividing, same base is dividing, their exponents subtract. And this will happen with all of them. 2 over 3 minus minus 2 and r minus 3 minus minus 1. So we get half minus 2 will be minus 3 over 2 q. 3 times 2 is 6 plus 2. This negative and negative will make it add, so they will add up and 8 over 3 will be the exponent. Then r is minus 3 plus 1 minus 2. So we got a equal to minus 3 over 2, b is 8 over 3 and c is minus 2. Question number 2. A particle moves in a straight line such that this displacement is s equal to 1 plus 3t to the power minus half. So we have to find the exact speed of the particle when t is equal to 1. They're saying speed, but when we differentiate s with respect to time, we get velocity. So what will we do? We'll just find velocity and we'll ignore the direction at the end. If it is negative, we'll make it positive. If it is positive, we'll keep it positive. So just find velocity. So differentiating this will be minus half comes in front. 1 plus 3t is unchanged, but its exponent goes down by 1. And further we have to multiply by the differentiation of what is inside the bracket, which is 3, because 1, its differentiation is 0 and 3t has a differentiation of 3. So it effectively becomes this 1 plus 3t to the power minus 3 over 2. Now they said find the speed when t is 1 second. So we substitute t equal to 1 in this. So 1 plus 3 times 1 is 3 minus 3 over 2. So which is minus 3 over 2, 4 to the power of negative 3 over 2. So to make it positive 3 over 2, first make it positive and then whatever is inside the bracket, reciprocate it. So 4 becomes 1 over 4. So now I'm doing it mentally. You can use your calculator if you want, and we get how much? Minus 3 over 2, and square root is half, and q will be 1/8. So the answer is minus 3 over 16 meters per second. But since it is speed, we will write it speed equal to 3 over 16 meter per second, because negative shows direction and we don't want to know the direction. Show that the acceleration of the particle will never be 0. So acceleration is this further differentiation of velocity equation, which is second derivative of displacement equation. So in other words, we will differentiate the first derivative again, this one. The constant remains constant, but minus 3 over 2 comes in front. 1 plus 3t again remains 1 plus 3t, but the exponent goes down by 1. Okay, so what do we get here? 9 over 4, and we had to multiply here by 3, I forgot, times 3, so it will be 27 over 4, 1 plus 3t to the power minus 5 over 2. uh, this this saying should not be equal to 0. It would prove that it is never 0. So let's make it 0 and then show that it has no solution if it is 0. So 27 over 4 is a constant. It cannot be 0, so ignore it. Focus on this one. 1 plus 3t, let's make the exponent positive here as well. Just like the previous part, this one, we reciprocate 1 plus 3 to make it 1 over 4 to make the exponent positive. So I'm ignoring this one now because it is equal to 0. So this, I'm assuming this is equal to 0. So 1 over 1 plus 3t, it is reciprocated, so its exponent becomes positive, and this is equal to 0. Now, to make it a 0, there is no possibility. Why? Because 1 to the power 5 over 2 will be 1, and 1 plus 3t over 5 over 2 equals to 0. And with the cross multiplication, if we do this, will multiply with 0 and 1 will be equal to 0, which is a wrong statement. So we already know that there is no solution. So that means it is not possible for a to be equal to 0. All right. Question number 3. A function is such that fx is ln 2x plus 1. For x is greater than minus half, write down its range of f. It is ln, nothing is adding, nothing is subtracting, so it becomes very easy. Every natural log or log for that matter, this is how the graph looks like. Okay, even with reflection, it remains going from down indefinitely to going up indefinitely. So since y has all the values from negative infinity till positive infinity, all the values, that means all real numbers are the range, part of the range. So range becomes fx is an element of all real numbers. If function g is such that gx is this, find the exact solution of g fx 13. G fx is also mean g inside the bracket fx, and which can be written as g, and fx is ln 2x plus 1. So in g function, wherever is x, substitute that by ln 2x plus 1, and we have just one x here. So it becomes 5 times ln 2x plus 1 equal to 13. Oh, so there is minus 7 also. Minus 7 equal to 13. So 5 ln 2x plus 1 equal to 13, and this 7 goes there, becomes positive. 13 plus 7, 20. Divide both sides by 5. Our focus is to find the x. Okay, so 5 and 5 cancel here. Ln 2x plus 1 equal to 4. Now if we remove ln from here, it means 2x plus 1 here, but the other side becomes e to the power 4. So 2x equal to e to the power 4 minus 1, and x equal to half e to the power 4 minus 1, and they're saying exact solution, so we got exact solution for this. Okay, next, find the solution of equation f prime x. Differentiation of fx is equal to inverse of x, so fx is ln 2x plus 1, correct? So f prime x in this case will be the reciprocal of 2x plus 1. This is what we do in case of ln, and multiply this further by the differentiation of the one we reciprocated, 2x. Its differentiation is 2. So we get 2 divided by 2x plus 1. Now let's find g inverse x. And gx is 5x minus 7. So to find inverse, what do? We substitute gx by just x, and this x becomes y. So it will be x plus 7 equal to 5y, divide both sides by 5, and we got our inverse. This y is the inverse. G inverse x is x plus 7 over 5. Now we have to equate this equal to this, because they are saying f prime x is equal to g inverse x. So 2 over 2x plus 1 equal to x plus 7 over 5. Now to solve such an equation, we should always do cross multiply. So 5 times 2 is 10 on the left side. 2x times x plus 7, 2x square plus 14x. Then 1 times x plus 7 is x plus 7. Let's bring this 10 also to the right side and simplify. 2x square, 14 and x, 15x. 7 minus 10 is minus 3. Okay, quadratic, and we cannot factor this. So let's use quadratic formula. So x equal to minus b. 15 is b for us. Plus minus b square 4 times a times c over 2 times 2. Okay, so what do we get here? Minus 15 plus minus is 225, 8 times 3, 24, 249 over 4. So we have two solutions for this. Minus 15 plus square root 249 over 4, and this one is minus 15 minus 249 square root over 4. What I got for this one is 0.194933, which is rounded off to 0.195, and this one is minus 7.6949, rounded off to minus 7.69. Question number 4. Okay, the diagram shows the graph of absolute fx. Okay, where fx is a cubic function, we can see, because of absolute, everything is positive. Find the possible expressions for fx. What are the possible expressions for fx? So whenever we have such a graph which is an absolute one, start with this. If they are asking you to find the fx, start with the leftmost side. It is positive, make it negative. Let's assume that this was reflected like this, right? That means there cannot be a shift here. That means a reflection here. It is not possible. So we continue. This becomes the part of the graph then, this one, right? This remains positive. That means that was reflected, but this was actual one, and this is, it reaches here, and the next one, it can't have a cusp like this. So you have to reflect that one also. So this becomes, this red color becomes your fx, and we have to find the equation of this red colored. So to find the equation of this, we should use this one, y equal to a first x-intercept, x minus first intercept. It is minus 2 here, so minus minus 2, which is x plus 2 actually. Then x minus second x-intercept, which is 1, and third x minus 3. I'm looking at the red graph only, okay, not the reflected one. I'm not looking at this one. I'm not looking at the one which is reflected, this one. All right. So to find the value of a, everything is ready now. We have to find the value of a with the help of this particular point, which is 0, 24, isn't it? It's a y-intercept of the graph. So in place of x, we will substitute 0. In place of y, 24. I will get a, because it is falling on the graph, so it will satisfy the equation. It will be positive, not negative. So 24 equal to 2 times minus 1 is minus 2, and minus 2 times minus 3 is plus 6, 6a. So divide both sides by 6. A comes out to be 4. So the first possible equation of the cubic function is 4. In place of a is 4, and then you can write x plus 2, x minus 1, x minus 3. Let's look at the second possibility. Second possibility is that this part was reflected, right? So this remains our original graph, this part, but we reflect this one. And this one was also original part, but this part was reflected, so we will write here. So this blue color becomes our second possibility, and we will use exactly same method, y equal to a x plus 2 x minus 1 is minus and x minus 3. To find the value of a, we need a point, and the x-intercepts are exactly same. That's why I wrote this. This time, if I extend this line, and this point will be reflection of 24, which is minus 24. So we will use minus 24 in place of y equal to a and 0 plus 2, 0 minus 1 and 0 minus 3. In this case, definitely we are going to get a equal to negative 4. So second possible function is negative 4, a reflection of the previous one, x plus 2, x minus 1, x minus 3. B part, what is it talking about? On the axis below, sketch the graph of y equal to absolute 2x plus 1. So like in part 1, we found the original one from absolute. Here, let's assume that this is the original one, 2x plus 1. Let's draw the graph of 2x plus 1 first, and then we will take care of the absolutes. So we know this is the format of an equation, y equal to mx plus c. M is the gradient, c is the y-intercept. Let's start with y-intercept. Here the y-intercept is plus 1. So let's say this is plus 1. The graph will pass through this. Now the gradient is 2. This is gradient mx plus c. 2 is the gradient. That means the rise will be 2. So let's say this is 2, this is 3. From 1, second point, rise is 2 and the run will be 1, because 2 can be written as 2 over 1, right? So this becomes our rise, this becomes our run. So here is this run, this is 1. Okay, and now I will connect the 2 points, and that becomes our equation graph. Here it is. Let me make it thinner. Okay, this is the graph, right? But this is the graph of 2x plus 1, not with absolute. For absolute, we will reflect the part which is negative. So from here, I will reflect the negative part upwards on x-axis. So it will become a V shape, and we will erase the one which is negative. So it's gone. This V shape will be the graph of y equal to 2x plus 1. Now let's go to the second one, which is y equal to 4x minus 4, isn't it? If I expand this, it becomes y equal to 4x minus 4. So gradient is 4, y-intercept is minus 4. So minus 4, let's go down, 1, 2, 3 and 4. This is the point from where we will start, because this is the y-intercept. Now rise 4, gradient can be written as 4 over 1, that means rise is 4, run is 1. So rise is 1, 2, 3, 4, we reach as 0, and run is 1. This is the point where we will join the y-intercept. So let me do that. First I will draw it, and then I will erase a part of it for a reason. Yes, this is the line, right? I'm reducing the size of this line because I want to erase the negative part and reflect it. So first let me draw the reflection of this specific part. So it will be somewhere pass through positive 4, right? Because it's minus 4 down there, so positive 4. All right. this is minus, this is positive 4, that is minus 4, right? Now I drew a shorter line because I wanted to erase the negative part, just like the previous equation I did. So two V shapes we got. The graphs, this one is this, and the red color is 2x, absolute 2x plus 1, done. What is the second part of this? Find the exact solutions of 2x plus 1, exactly same, where basically the exact solutions are the points where they are meeting. This and this. And this is solution. Is there any y here? No. Only x's are there. That means we need just the x coordinate. We can use our graph, but I don't think our graph will give us such a correct answer. Okay, according to graph, one answer is x equal to half because it is exactly in middle of 1 and 0. And this one, we can't be sure about this. Maybe 2.5 or 3. Okay, let's say 2.5. But there is an algebraic way of doing this question. Let me do that way. Okay. Whenever we have such a situation when both the parts are having absolute, there's no need to worry. You just write this as a normal equation first. 2x plus 1 equal to 4x minus 4. Because we don't know what is inside, positive or negative. If both are positive, we'll get this situation. If both are negative, they will cancel out and we'll again get this situation. So these two situations are represented by this, and let's find the solution. 2x minus 4x equal to minus 4 minus 1 minus 2x equal to minus 5, and yes, it is giving us minus 5 over minus 2, which is 2.5. That was the assumption here. 2.5 is correct. Now second, another situation could be that this is negative but this is positive, and this is negative inside the absolute signs I'm saying. Okay, but in both the cases they are same, because if I write minus or to the left or the right doesn't matter. So this is what we will use now to find the solution, second solution, and we are expecting x equal to half. So minus 2x plus 1, let's change the sign of this one but keep the other one positive. Minus 2x minus 1 equal to 4x minus 4. Let's take this 4x to the left side, minus 2x minus 4x, and bring minus 1 here, minus 4 plus 1. So minus 6x equal to minus 3, x equal to negative 3 over negative 6, and yes, we got half. So yes, the two answers of these are half and 2.5. We did not take the help of graph. We did it algebraically because they're saying exact solution. Graph cannot give us exact solutions. All right.